Hello all, welcome to part 9 of the Windows Assembly Language Primer for Hackers video series. In this video, we will look at how to use loops in assembly language. Loops. The instruction set for loops, well, the easiest one is the loop instruction itself. What this does is it will decrement the CX register, and when the CX register becomes 0, the looping will end. Variation of this uses both the CX register as well as the 0 flag. And you have loop E, loop Z, loop NE, so on and so forth, where all these suffixes after loop can almost compare it with the jump family of statements. Now in this case it is more of an either or, in the sense either CX register decrements and becomes 0, or maybe the 0 flag is set. When any one of these conditions are met, then appropriate action is taken based on if it is loop Z or loop NZ and so on and so forth. Now the MASM assembler, a programmer's guide, specifically says that the loop instruction cannot be greater than 128 bytes from the start of the loop statement, right? So which actually means that loop can only jump to maximum 128 bytes and execute instructions. Let's take a simple example and figure this out. You can download the program loopdemo.asm. Let me open the program here. We probably actually first go ahead and increase the font size a bit. Seems better. Okay. Now this is the program for loop demo. This part I guess all of you are already familiar with. After this we have the data segment in which we have a simple string hello world. Now from here on we will go ahead and create a simple looping instruction. We will just use loop, and hence we will only depend on the CX register. So the first statement goes ahead and makes the ECX register 0, right? Because XORing with itself would actually imply that everything becomes 0. After that we move the value 20 into the CX register, which is the bottom half of the ECX register. After that we define a label called start loop. Then we push the ECX register because we are going to go ahead and invoke an API, std out to print hello world on the screen. Then we pop the ECX register back into the CPU register so that we retain the value, and then we loop to start loop. The point to note here is that the CX register is automatically decremented by the loop instruction. That is why we do not have a dec ECX or a dec CX anywhere in this entire loop. So this loop continues for 20 times and then exits. Let's look at a demo. Already compiled the program, simple to compile. And as expected, we have the word hello world written 20 times. Right? Let's go back to our slides now. The next instruction which can be used for looping is the while loop as well as the repeat until loop. So while we are all familiar, even in high level languages we have something similar. So while, and after that you mention a condition till the while loop is going to carry on. Similarly, repeat until a particular condition is satisfied, right? So till the point this condition is satisfied, the while and the repeat loop will keep continuing. Now we may recall that the break and continue statements are used to go ahead and exit the loop either permanently in the case of a break or just for that instance of the looping in the case of continue. Now the interesting thing about MASM is that along with the break and continue statements, we can even add an if condition. So let's understand all of this with the help of a simple example where we demonstrate both the while and until loops. So this is done in a file called while demo. Awesome. So on the top we have the typical declarations which we always do. Then after that we have the data segment in which we have two strings defined. This is string 1 and this is string 2. We also have the carriage return and the line feed at the end of these strings, and then we null terminate them. And then we have two counters defined in memory of size 4 bytes called counter 1 and counter 2. Now the first thing we will look at is the while loop. Now what we are doing is we move the value 10 into counter 1 and then we run a while loop using counter 1. So while counter 1 is greater than 0, invoke std out and print string 1 and then decrement the counter by 1. Very simple example. Of course this is going to continue for 10 times. Now again we go ahead and do the same thing for the repeat until loop, where first we load counter 2 with the value 10 and then we have a repeat until loop where till the time counter 2 does not become 0, we will go ahead and repeat this statement. So we go ahead and call invoke std out giving the address of string 2 and then we decrement counter 2. Note that in while loops as well as in repeat loops we have to decrement the counter ourselves, while in the loop statement the CX register is decremented by itself. This is a key difference. After that we exit the program. Let's go ahead, run this. As expected, we have string 1. Okay, I think I need to assemble this first. While demo. And then let's go ahead and link it. Then let's run the file. And as expected you have this is string 1 being printed 10 times and similarly this is string 2 being printed 10 times. Now within the same functionality, let us explore how the break statement works. So in this case, inside the while loop, let's say I add a break statement, dot break. Now the moment I do this, the first time this gets executed and break is hit, immediately we will exit the loop. So because of that, the invoke std out and printing of this is string 1 will only happen once. Let's exit this. Let's go ahead, assemble it, link it and then run it. And as expected, this is string 1 is only printed once. Now if we go ahead and add a break statement here in the repeat until loop, the exact same thing happens. Will there be a difference? No, right? So this is string 1 and string 2 gets printed. Now in case of MASM, we can even have conditional breaks. So here I can actually say break if, right, counter 1 equals 5. Probably enclose this in brackets. And here I can once again put a similar condition saying if counter 2 equals 5. Note that any logical condition could have been put there. And as expected, both these statements are printed individually 5 times. Similarly, we have the continue statement as well. In case of continue, what happens is that the execution of the later statements in the loop stop and the next iteration of the loop starts. So we can actually put a continue here. Let me remove this break as well. Now in this case, what would happen is nothing would get printed in the first case, which is this is string 1. And if we actually run it, it hangs. The reason that happens is if you actually use the edit command, you would notice that the continue statement is even before the decrement statement, because of which the counter never gets decremented and this becomes an infinite loop. So let's go ahead and do this a bit differently. Let's place the deck part here, and then let's place the continue statement here. Let's remove the decrement statement from the below line. Save this, exit, assemble, link, and then run. And if you notice, this is string 1 did not get printed at all, right, as expected. Now even in continue, we can go ahead and actually add a condition. You can actually say continue if counter 1 is less than 5. In this case, what will typically happen is only the first 5 occurrences of this string 1 will be printed. The rest will not be printed. Anyway, so coming back, very simple demos to understand the while, the until loop, and the plain vanilla loop itself. Well, that's all for this video. Please leave some comments behind, and hopefully you enjoyed this video. Bye bye.